Welcome, LibreGraphics Meeting 2026. Nice to be here. Thank you for inviting me. Today I'm going to present to you Liblast 3D Asset Pipeline. First, I've been making videos about music production with Linux and free software for like 10 years. For like 5 years, I've been working in the video game industry, making 3D art and technical art, so shaders, textures, models, but also sound. I've shipped a few commercial games, most recently as a technical artist, as a sole technical artist at Rally Mechanic Simulator. Car Dealer Simulator, I think, is in early access, but I also did all the tech art stuff there. Lots of simulators. And for about 6 years, so like 2020, I started doing Liblast. I'm also married, I have 2 cats, and I have ADHD. So what is Liblast? Liblast is a non-commercial project to build a family-friendly online sci-fi first-person shooter game with only free and open source software tooling. Cool robots and explosions, of course. It's a proof of concept for a fully Libre production pipeline. So basically, I want to show that, hey, we have free software that can do everything that is required to make nice games. And, well, we don't have a complete game yet. We have a working prototype and free rewrites, but I'm getting ahead of myself. A motivation for making this was also that all of the free and open source first-person shooters we have are running on some form of Quake engine, and that's old. And also the game design is mimicking Quake 2. So I thought, well, we can do something new maybe, finally, after like 20 years. Also, making open source projects is a good way to make friends. And so, very brief history. Started in 2020 with my friend Jan Hemstra. Then I rewritten it on Godot 4 before it was in alpha. It was a wild ride, but I helped fix a lot of bugs in the engine. We got a playable version of the game with bots and a public server running all the time. Actually, it's still up. You can download the legacy version from libla.st and play it right now, I think. But it's slow, it's a mess. I had to rewrite it. So around 2024, I started again. Learned a lot about software development because I'm no programmer. The best I could say is a mediocre coder. Like what I do is Bash and a bit of Python. So I had to learn. And in 2025, I started yet another rewrite, this time splitting the game into a framework and game so that the technology developed for the game is reusable for other projects in the future. There's some notable contributors without whom this would not be possible. So Joost Freeman has helped kickstart the 2024 rewrite, and this talk wouldn't be here without him because he brought me inspiration for developing this art pipeline. So huge thanks to Joost Freeman. There's many more. I don't want to spend too much time because we have only 15 minutes left. But there's wonderful people who are instrumental in making this work. Okay, so we can make pretty pictures. But why and how? So one thing I wanted to do is let us have one model look in many different ways. So if you pay close attention, this is the same model, but every instance has scratches and dirt in different places. So the problem with traditional asset workflows is that you make a high poly model, then you make a low poly model, then you work to transfer the detail, the geometric and other hand-painted detail from the high poly model to the low poly model using textures. This is great. It allows a lot of artist control, but it's very expensive. And any iterations require a lot of churn because you need to get back to the high poly model, paint stuff, then bake again. Then you have problems with baking. So I wanted to do something that will allow us to make models very quickly, very easily, and have them look great like that. The same textures that are used for that robot are used for this shipping container. It's the same few textures, and I'm going to go through what they are in a moment. This is another view with a bit of more environment textures. We have some tiles, and you can see that there's some grunge and stuff in the cracks. There's walls. There's also, you can see that it's hard to spot any tiling on the wall. That's because there's multiple textures. There's a world space noise texture, which is used to break up repetition. It also helps blend assets together, because if you put a bunch of rocks, the world space noise are gonna create patches of dirt that are spanning multiple rocks, for example. So what if I told you that indie games don't have to look ugly or ancient and be all about pixels, and we just need a few good textures and a good shader? Open source software can do all of that. And that modeling without worrying about making custom textures is really fun. And I'm saying that as someone who spent a lot of time also professionally making textures for models. So, and also I've done the hardest part already, so you can just enjoy the work and have fun. Let's do a live demo. This isn't it. This is code for the shader. I've written this from scratch, and that's pretty much it. So let's play an animation and play with this a bit. So this is a robot, and this laptop is super old and not very powerful. There's like a what is the GPU again? NVIDIA GeForce 8830M. It's like on PCI Gen 2. What the heck? Like, so it's you can run Quake Free Arena and Unreal Tournament from 99 on this laptop, but not much else. But it's rendering this, and actually looking pretty smooth. Okay, so the thing is, the shader I've created makes use of multiple reusable textures. I'm going to disable features one by one, and you'll see what they do. So first thing, let's disable normal maps. Bloop. Now it's looking kind of flat. You can see that, maybe I'm going to scroll the animation to a different place. Well, this is a good one. So you can see that normal map is providing all the edge bevels and also some details, some features that, well, without this, if I also turn off this stress, that's all for the base layer, okay. Then it's looking kind of low poly, because it is very low poly. If I show just the lighting, this model is super choppy. This is really not high poly model. This is not mid poly. This is like, there's 7,000 triangles in this model. Let's get a wireframe. Yep. This is chunky. So models like that were in games from like 2001. But with using a bunch of textures in a smart way, we can make it look like this, which seems pretty close to what you get with the traditional high poly to low poly workflow, only, well, yeah, 16 watts of heat from this GPU. So this model has 7,000 triangles, which is nothing. The whole scene runs with 94 megabytes of VRAM used, which is, I mean, this runs on the phone. This runs on my Fairphone, and probably a bit better than on this laptop, honestly, because the phone is recent. It's a Fairphone 6. There's no dedicated textures, so you don't have to make any textures to make a model like this or 1,000 different ones, because all the textures are made to be reusable. There's no high poly modeling, no baking, no painting. There's one shader, one material, and this draws in one draw call. So what is this all about? Textures are a huge bottleneck in making 3D assets look good. They're very expensive to make. They're very expensive to iterate on. They take up a lot of space. And working with high poly models is a pain, especially bevels and then baking bevels. My God. Also, RAM and VRAM are not getting any cheaper recently. So if we can cut down on memory use, that's good. Also, having the game be very small, like a couple hundred megabytes, allows us to host the game on the web and have an HTML5 version, which people can just play in a browser. And because it's tiny, it loads quickly. If our game is 20 gigs, it's never gonna load for people, but this can. So my idea was to try and remove all the redundant work from making 3D assets. And redundant work is, for example, making bevels. Bevels is what takes things from looking like old video game stuff to looking like, oh, that could be real. Also, grunge, scratches, dirt, chipped paint. This is stuff we do all the time, making game assets. Like, really, like you just throw these effects in Substance Painter, and then you bake that down to custom textures, and you blow out your VRAM budget really quickly. Or you have to have ugly pixels. So all of these textures are reused for all models and are done already. And so because we're doing them just once, we can also spend more time polishing these textures so they're nice, instead of just using the stock presets from Substance Painter over and over, which looks copy-pasted. Yep. So for dynamic objects, we also can randomize the UVW coordinates of textures to avoid. We need to lock it down because normally the textures for scratches are mapped in world space. So when you move the same rock over, it's going to look differently. But for dynamic objects like characters, we need to lock it down, but you can offset it. And actually, the game is offsetting that automatically so that every character model looks different. And one of the very important pieces is baking geometry information into vertex colors, because just having edge bevels mapped with textures is not enough, because then in crevices, you have like scratch marks in concave places where there shouldn't be any scratches. But we can bake that information into vertex colors and bring it over, and our shader will say, okay, that's a crevice. There's no scratches there. There's dirt. So the most important tool here is a plugin for Blender. It's a free plugin. It's called Dream UV, made by Bram Eulers. I don't know if I'm pronouncing that right. He made it working on Half-Life Alyx, as far as I'm concerned, at Valve. And it's a wonderful add-on. You need to make an atlas for it, but I made one. You can just use it. It unwraps rectangular patches on your model, finds the appropriate part in an atlas. So here I have two segments for edge bevels. There are rectangles of different proportions, and Dream UV finds the one that matches best what you've selected on your model and just conforms it to that rectangle. There's also various details which I can put on the model and make it look like it's high poly model detail baked. It is modeled because this atlas was made in Blender and baked using GrabDoc, another instrumental add-on, but it's done once and then reused over and over in the entire game. So this is how it looks in Blender. There's a leg of a robot, and you can see parts of it are mapped to these rectangles. Also, we have other parts which are mapped to the details for like different circular details or like a crevice. Okay, there's overlays. Another thing we need is painting our metals, plastics, and whatever, because that's what the world has a lot of it. Some coats, and all of these coats and paints, they generally fade away, scratch, and become interesting. So I've created a special atlas that is used just for details painted. This is the atlas. So this is reused for the entire game. You can put letters and digits. You can put simple symbols. You can put different stripes in your models. Most of them are white, so you can tint them in the shader. The shader has 4 layers, so you can have 4 different layers of paint. You can also use custom texture for everyone. So it's not like you can't use custom textures. There is one prop in the game which uses a custom texture just made for it, but it's just one small texture. Everything else is reused. So this is how it looks in Blender. I selected parts of the model that have details printed on from this atlas. Distress masks. So we need all the scratches, grime, and dirt, and grunge. And the most efficient thing is to pack this all into a single texture. And we can sample this then using UV2 for dynamic objects, or maybe UV3 if you're using for static objects. We can do box mapping, and it looks like this. I've made in Material Maker, made all these. Actually, it's one project, but it takes a lot of VRAM to load this, so I can't do it on the laptop. Sorry. We have 4 different kinds of grunge, and they are all packed into a single texture. So we can fetch all of this with one texture read on the GPU. I've designed a material texture system with kind of custom texture packing to make it as efficient as possible. RGBA is standard. ORMD is an extension of the classic ORM map that is used in many PBR renderers, which is occlusion, roughness, metallic. And then I use the alpha channel, call it data, and we can use it for different things. It can be an additional grunge mask, which is correlated with the material type. So for example, if you have bricks in your data channel, you can have grunge of, for example, streaks of rusty drips from between the bricks. So it correlates with your texture. And then this is modulated with other noises to produce really nice dirt. And then, last but not least, CXHY, which packs curvature, normal, and height in a single texture. So I sampled this for parallax occlusion mapping to make it seem like there is actually 3D model detail where there isn't. And I use this, of course, for normal mapping. And curvature is very, very important for letting my shader know when we are close to an edge. And that helps map the scratches and other effects. So these CXHY maps are non-standard, so they cause a little friction in the tool chain, but they afford us a lot of power. So I think it's a good idea to adopt this. UDIM variants. So if you go to the UV space, it's a rectangle. But if you move out of the rectangle, now you're in UDIM 1. So we can use that to tell the shader that parts of our model are in a separate group. And these groups are used to color the model in different ways. We can alter metalness, roughness, normal map power. Vertex Color Baker, it's a custom script in Blender. I'm going to show it tomorrow on the workshop. World noise, 3D space, synthesized by Godot. So what this does is let us have a single model, and also using per instance uniforms in shader, I can have every instance in the game world have different amounts of grime and grunge and different colors of dust and dirt. There are some problems that I've learned the hard way during developing of this whole workflow. I'm not going to go into them because I have 1 minute, but tangents are necessary for UV maps, for normal maps to work, and it's not trivial to get them right, and you can really easily mess it up. Always select the first UV map if you export. UV map order in the GUI doesn't matter. It's just fake. We need to use specific versions of everything because otherwise things don't work well. And light maps, Godot by default uses UV2 for light maps. So if we need that, we need to move it to UV3 or something because it's going to overwrite that. Here's talks and presentations that I've used as an inspiration for this whole thing, and you can use that as further research if you want to get into this. And if you want to try it right now, you can go to liblast.st, click on code, and get the gits. Just don't download because it's going to give you a zip without the assets. You need to git clone with git LFS. Questions? Yeah. Did I make it in time or what?
You made it amazingly in time. Thank you. It was a blast, a Liblast. So we have questions? Very good. Because Thomas needs to set up himself.
You talked, so this seems like a lot of hard surface stuff. I wonder if you've also worked with like flowing water and water interactions.
Come again, please.
So does Liblast, is it mainly for like fully meshed out models? I wonder if you've done other work with water, like waterfalls or flowing rivers and things like that.
That would be kind of a different beast. I don't think this would be useful for like rendering water. I think I would have to make a completely different shader for water. But it could work for rocks, garnishing the river and sand and, foliage and stuff.
So what are the tools that you typically use, like besides Blender and Godot, in your everyday work creating this?
So what I'm using is Material Maker. Right, this should have been in a slide. Yeah, so I'm using Material Maker, which is a program made in Godot for making procedurally generating textures. It's node-based, it's open source, it's free, it's amazing. All of the textures here, including these little like splashes I put under text, are made with Material Maker. And I've used Material Maker in like professional work to make environment textures and everything. It's amazing. The Material Maker, yeah. Also Inkscape for stuff like the Paint Overlay Atlas.
Great. Any more questions? There's one more question.
You mentioned that the texture work was a big driver of sort of getting these a bit more economic workflows where you use less processing power and so on. Do you, beyond this aspect, also have like ambitions to go even smaller, even more compact, being able to run on even slower machines, or is that not really a factor for you?
Yeah, I'd like to be able to scale down to very low-powered hardware, so this could run on phones and like Raspberry Pi 4. But well, there's work to be done for optimizing and maybe making shader variants. Because yeah, so far you can like globally disable different effects, but it doesn't speed things up that much. That's all the time I have.
There's a workshop tomorrow. Attend it. Thank you very much.
Thank you so much.